In this video I will demonstrate testing a claim about the population mean for a large sample. Test the claim about the population mean where mu is greater than or equal to 45 at the level of significance alpha equals 0.05. Sigma is given as 3.2. The mean of the sample, x bar, is 44.1 and the sample size of the SRS is 50. Assume the sample came from a normally distributed population. We will use the p-value method for this video. First, we need to write the null and alternative hypothesis. The claim is that mu is greater than or equal to 45. Since the claim includes the statement of equality, is equal to, this will be our null hypothesis. The complement, which is a statement that must be true if h naught is false, contains the statement that only includes an inequality. Therefore, for this problem, h sub a is mu is less than 45. Regardless of which of the three possible pairs of hypotheses you use, you always assume that mu equals some number k and examine the sampling distribution based on that assumption. Some authors always write the null hypothesis using the equal symbol. For our problem, some authors would write the null and alternative hypotheses as mu equals 45 and mu is less than 45. However you write the null hypothesis, you will follow the same process. Whichever set of hypotheses you use, when the TI-84 asks for mu naught, you need to insert the value associated with h naught. Finally, before we turn to the calculator, the line that begins with mu colon is where you use the symbol that you chose for the alternative hypothesis, or h sub a. Go ahead and turn your calculator on. First thing we're going to do is we're going to clear out our equations by pressing y equals and then clear next to each equation. Might as well turn off our plots by arrowing up to plot 1 here and turning it off by pressing enter. Press stat since we're testing, hypothesis testing for the mean for large samples, and we know sigma, we're going to do a z-test, so either press 1 or enter. And then we have statistics, we don't have data for this problem, so we're going to enter our mu naught will be 45. Sigma, as you recall, was 3.2. X bar is 44.1. And our sample size was 50. Mu, the alternative hypothesis that we're testing is that mu is less than 45, so we're going to choose that one by pressing enter. We're going to arrow down, arrow over, and have the TI draw the curve, the normal curve for us. And so our results are that z is equal to negative 1.9887, and our p-value is 0.0234, and we have just a little shading, relatively small amount of shading. Now, a different way we can do it, if you don't really care to see the drawing, we can press stat, still arrow over to test, still choose the z-test. You're still going to have statistics and all the same data, all the same values, but instead of drawing, we're going to calculate. So press enter when you have calculate highlighted, and we find out that for mu is less than 45, we get the same values, a few more digits. Z equals negative 1.988, P equals 0.0233. Now, to finish the problem, if you haven't already done so, confirm that the conditions are met for using the z-test. For this exercise, the conditions were met since it was a simple random sample from a normal distribution. Report the test statistic, z, and report the p-value, p. If this was a problem in context, we would at this point return to the practical question. First, however, we determine if we should reject or fail to reject h naught. Compare p with alpha. P is approximately 0.0234, which is less than 0.05, which is alpha. The smaller the p-value, the stronger the evidence against H0 provided by the data. Small p-values show that the observed result is unlikely to occur when H0 is true. When the p-value is smaller than alpha, we say that the data are statistically significant at level alpha. For our exercise, we will reject H0, or in other words, reject the null hypothesis. We can also say that at the 5% significance level, there is enough evidence to reject the claim that the mean is greater than or equal to 45.